the I did some type of calculation of what you could say the progress grade. Okay, so now I think it is a very good snapshot of everybody's grade as of today, right? Which means if you do the next assignment, that progress grade will be, I mean, it's gonna, so it won't be valid anymore, right? So it does give you an idea of what is your grade so far, but it's not, I mean, what is in, yeah, what is in so far, what is in is about 24%, you see? So which means 76% is outstanding, right? So if you get a good grade right now, you have a good grade over 24% of the whole thing. If you got a bad grade right now, which means you have a bad grade over the, on 24%. So everything can change, right? A good grade can become better, a bad grade can become a better grade, and vice versa. A good grade can become like an F at the end. So everything depends on how the students are going to pursue, right? So now some of you, for instance, are not doing the My Open Math normally as they should. So now you're going to see it every time. If you give up on 10% of the whole grade, you're going to see it at the end of the semester, right? If somebody does not do the My Open Math, as annoying as it could be, right? If you don't do it, so you're gonna see your grade will not be like the one you are expecting. Okay, you see, it does help. So by itself, do the My Open Math by itself make somebody pass? Of course not, right? Even a single test does not do it, but it does help or it does hurt. Okay, so okay, this is the reading that we should do on the progress grades. The reading is, if I have a bad grade right now, what should I do to get a better one? And you can see also sometimes how frustrating the grading is in my 083, which means if you have a 68, you still get F, right? That is frustrating. If you get a 68, you still get F. If you got 69, it's still F, right? So you have to avoid to be in that category. That is really not cool at all. Okay. All right. So other than that, so we're gonna continue our class. I think last time we talked about the radicals, how to add radicals. This was this was our class last time. So let me get. So, and radical expressions add subtract radical, right? Okay, this is, so I'm gonna give you a few problems to do before we move on to the next topic, right? Which is a multiplication of radicals. So I'm gonna give you a few topics here. And meanwhile, I'm gonna show my, share my screen, all right, which is here, loading, okay, all right. So window, I'm gonna document.
You're not having our quiz today?
Yeah, it's gonna be open at the end of the class.
Oh, at the end of the
We're gonna talk about it. We're gonna talk about it right at the end of the class. Just like quiz number 1, it's gonna be open, and you will have about 24 hours to complete it. Okay. So do this, add and simplify. All right, so you have three radicals. I think, we can say fairly, these are the type of stuff you can see in the test, in this topic, right? Or in the quiz, okay? So try to do them, right? So I give you like, at least 5 good minutes for everybody to try to do them. All right. So can I have somebody, who's going to try to tell us what they did for the first one, please? Can I get a volunteer?
I can.
Thank you. Go ahead, please.
The 27 with a square of 2, you can't really do anything to that. The 18, I broke it down for 9 and 2.
Yep, 9 and 2.
And then the square root, the 9 is 3. So it'd
Yep.
be 5 times 3.
The
square root of 2 left over. And then the plus 2 on the end.
Yes, plus, okay. And then plus square of 2. Thank you. So, and then next?
And then I just did the 9. I'm sorry, 5 times 9. I'm sorry, 5 times 3 is 15.
Yep.
So it's 27 minus 15. And which is 12.
Which is 12, and then plus?
Plus, I wasn't remembering if I was supposed to do the 1. So it's plus 1.
Plus 1, exactly. Okay. Because that number in front of the squares of 2 is 1 right here.
Okay, I did leave that out, but I fixed it. So it's going to be 13
with
the square root of 2.
Thank you very much. That is exactly the right steps. 13 squares of 2. Everybody see that? Okay, so this is very likely what you're going to see in the test in this topic, right? Very, very likely. At first, the radicals don't match at first, but then when you do simplify, we get some match, right? Okay, so the second one, who's going to tell us some steps about the second one? Please.
I can.
Go ahead, please.
Let's see. So let's see. I broke down the 45 to 9 and 5.
Thank you.
The 9 breaks down to 3.
So the 9 becomes 3. 9 is 3 times 3, right?
Right.
Okay. So now, what's going to be 12 times what number at
3
times 3, and then
the 5 is left inside.
The 5 that's inside, right? Thank you. You see. Then next.
And let's see. 20 would be 4 times 5, but the 4 can be broken down to 2. So that's there. So the 2 comes out, and the 5 is left.
That is absolutely right. Yeah. And then the last one, 80.
For 80, I did 8 times 10, and that can be 4 times 2. Then the 4.
So do you have better than that? You say 80 and 10. I think there is a way to break it down which is a little bit better than that. If you think about it, 80 is of course 8 times 10, but neither of them is a perfect square. So this will give you more work basically, but there is another way to break it down, which with a perfect square, another number. What is that way? Somebody?
16 and 5.
16 and 5, thank you. You see?
Who was that showing off when it's my turn? How dare you? Just kidding.
I don't know who that. Peggy, stop doing that.
Yeah. So 16.
Okay, so 16 is So you pull out the 4.
Uh-huh.
So
So
4 times 4.
exactly 4 times 4. And then you have square root of
5.
5 left. Thank you. See? That, that's good. That's really, when we hear, we're almost done. So 12 times 3 is what?
36.
36 root 5. 7 times 2 is?
Minus 14.
Minus 14 root 5. And then 4 times 4 is?
16.
16 root 5. All right. So now we just group the numbers. 36 minus 14, which is 22.
And then plus 16 is 38.
38 root 5. Thank you very much. That is absolutely the right answer.
Thank you.
Thank you. All right, and the last one now is the cube roots. Now, what numbers, some numbers that were considered to be nice numbers, they are not anymore nice numbers, okay? All right, so 24. What way we break down 24 if it is about cube root? What numbers we have to use?
3.
8 and 3, thank you. Because 8 is a nice number. How much is cube root of 8?
2.
Is 2. So we have 13 cube root of 3 minus 9 times 2 cube root of 3, which is 18 here. So 13 minus 18, which is negative 5 cube root of 3. All right. So this is actually, these are the same examples you're going to see on the test, stuff like that, okay? So these are addition or subtraction of rational, expressions. Now the next topic will be 3.4, which is how to multiply or how to divide radical expressions, right? Multiplication and division of radical expressions. So multiplication to 3.4 and division of radical expressions. Okay, so we're gonna start with a very useful formula, which is when you multiply, we say a nth root of b, right? You see that you multiply by another radical, which is c nth root of d. If you multiply these two radical expressions, right, what is you gonna do? You're gonna multiply the a and the c together, right? You're gonna multiply a and c together, it's gonna be ac. And then you are free to group the two under the same radical, BD. If I see that, if it is a multiplication, so you multiply the radicals together and you are free to group the two radicals together. It becomes only one radical, right? Okay, so for instance, if I have to do 7 square root of 2, 7 square root of 2, right? Times 5 square root of 8. If I have something that tells me to do this, right? What can I do? I can go ahead and just multiply 7 by 5, right? It's going to be 35. And then group these two under the same radical, square root of 16. Okay? Now, if my number that I get is a nice number, I try to simplify. If it is not a nice number, I'm done, right? But 16 is a nice number, so squares of 16 is known, is 4, right? So in that case, I don't stop right here. I keep going because this is 4, and 35 times 4 is 140, right? But here, what we are learning here is when you multiply two radicals, this is the way to do it. You multiply the numbers outside together, and you group the two numbers inside, right? This is, for instance, you tell me what to do here. If you have 6 square root of 3 times 9 square root of 7, right? How can we simplify this expression? Can somebody tell me what you do?
You multiply 6 times 9.
Exactly.
And then 3
9.
times 7.
Yes. So how much is 6 times 9? 54, right? And then when I do 3 times 7, which is 21, I have to put it under the radical, right? Don't forget the radical. When you multiply the numbers inside each radical, don't forget to the radical, right? If I see that, so now, you see, in that case, square root of 21 is not a nice number. I just stop right here, okay? I don't have to do one further step. I'm done. Square root of 21 is square root of 21, right? Okay, so tell me, what do you think here is 8 cube root of 5 times cube root of, for instance, 10, right? What do you think it's going to be? How can you rewrite this?
8 and the cube root of 50.
Exactly. You see, because that number in the second radical, what number is in front? That's why we don't need to write.
1.
It's 1, right? That number is 1 in front. We don't need to write it down. It's going to be 8 cube root of 50, right? Okay, so this is a basic about this formula. So now we're going to apply it when you have a whole expression to calculate. We're going to apply this stuff right here. So let me keep up some example from the book, right? For instance, we say,
Did we lose you?
Um, it seems like he froze or something, maybe? He'll be back. He'll make it work.
Hey, he's like the Terminator. He'll be back.
Break time.
Okay, so you hear me? Can you hear me?
Yes.
I can hear you now.
Yeah, I mean, something happens, you know, with the internet here at CCBC, you know. All right, so I guess I still have to share my screen. Let's see. That's not good at all. Okay. All right, so I hope, you know, we don't have that again. I was talking to myself. I even didn't realize the internet was gone. Okay, so right here, you see we have to distribute, right? The first, when we distribute the first one right here, can somebody tell me what we get? The first term multiplied by the other one, what we get? We get
35. I believe that'd be negative 35.
No, I mean, no, I'm talking about the first term. Is this one times this one right here? Do you see?
Oh, the 6x minus 24.
Yes, the 7 root of 6 times 3 root of 10. How much we get? The first
that
one.
would be 21 square root of 60.
Thank you. 21 square root of 60. Everybody agrees with that? We are just practicing what we wrote here, right? It's going to be 21 times square root of 60. All right, the second arrow here, the second distribution, what's going to be? Minus what?
35.
Uh-huh.
And the square root of 90.
Square root of 90. And 90 coming from 15 times?
15 times 6.
Times 6. You see? All right, so this is what we're learning today. We're learning how to multiply radicals. Now, if you get nice numbers, now you have to continue to simplify them. If you don't get nice numbers, you are done, right? Okay? But here, unfortunately, here we got nice numbers, so we have to keep going, right? I say unfortunately because if these two numbers were not nice, we would stop right there, okay? But they are nice numbers, so we have to keep going. Okay, how we break down 60? What you gonna use?
It'll be 12 and 5.
Yeah, 12 and 5 is the first trial, but we have a better breakdown than that. We have better numbers. Is 4 and 15, right? 4 and 15. And 90, how we break down 90? Of course, everybody gonna tell me what? Everybody gonna tell me 9 and?
9 and 10.
9 and 10, right?
So
okay,
it doesn't the same, like we're not trying to get the same.
No, we're not trying to get the same. Here we just, you know, we're just doing what we can. If by coincidence they can break down using the same numbers, it's okay. That's good. If not, we're just trying to do the maximum we can do, right? Okay. But again, what are we learning in this topic today? We are learning how to go from this step to this step. This is what we're learning today. Okay. Now, the next step is that we did before, right? Is in 3.3. That's the next step, you see, how to simplify this, or even in 3.2, I think, okay? But what you're learning today is how to multiply radicals, right? Okay. Which is the very first step you see here. So now the 4 comes out, it becomes a 2, right? It's going to be 21 times 2, root of 15, minus 35 times 3, root of 10, right? Which is 42 root of 15 minus 105 root of 10, right? Okay, so this is how we multiply radicals. So let's see another example where we have a full parenthesis multiplied by another full parenthesis. So basically, we have a full parenthesis by another full parenthesis.
Wait, can you go back a little bit?
He went all the way back. He went back to out of here.
All right, so everybody, can you hear me?
I can
Yes,
hear
I
you.
can hear you.
Yeah, I mean, something is wrong with Teams today. I'm sorry about that. That is, you know, I'm at CCBC here, so I'm using CCBC internet. So, but okay, so right here we have this one. You see this one now? This one is more complete. It is a full parenthesis multiplied by another full parenthesis, right? But we know what is the distribution process, right? Don't we? We know we have to FOIL. We have to FOIL, right? The only thing here, every time we FOIL here, we are ruling. I mean, the expressions they have radicals in them, right? But here we have to FOIL. We have to multiply everybody in the first parenthesis by everybody in the second parenthesis. Okay? We have to multiply everybody in the first parenthesis by everybody in the second parenthesis. So let's do it together. So this one right here, the F, the first ones, this times this, how much is that?
It's going to be 14 and the square root of 10.
Thank you. 14 squares of 10. That is the first ones. The O, the outer, which means this times this. How much is going to be?
Minus 16.
Uh-huh.
How do you say that?
Square root.
The
Square root of
35.
Thank you. That is absolutely correct. And then the next one, the I, the inner. How much is that? The blue stuff, the blue arrow. Minus what?
Negative
Somebody.
21. 21 square root of 12.
21 squares of 12, right? Okay, now comes so what's going to be the last one here? The last one is plus what? Plus 24 squares of what number? 42. You see, everybody? This is the first step. This is what you're trying to learn today. Now, what comes next is, if applicable, is to simplify if possible, right? If you cannot simplify, we are done, okay? If I cannot simplify, I'm done. If I can simplify somebody, then I go ahead and simplify them. For instance, which one here you can simplify, you think? Which radical you can simplify?
12.
The squares of 12, right? Everybody agree with that? 12 could be broke down into 4 times 3, right? So 4 comes out, it becomes a 2. So it's going to be 14 root of 10 minus 16 root of 35. And then the 2 is multiplied by 21, which is 42 root of 3. And then plus 24 root of 42, right? I don't think we can do a further, I don't think we can do a further simplification here, because 10 is not like a number that you can break down, you know, into nice numbers. 35 is not, and 42 is not, okay? Which means we are done. All right. So that is this one right here, and then let's try to see an example, another one which is a little different. Okay, so we have, for instance, I mean, let me just write it down. How you would do this? Okay. Okay, so let's do this one together, right? And you're gonna help me do it. So right here, the first one, what you gonna do here? The first one.
It'll be 6 square root of 35.
6 square root of 35, right? Thank you. And then the next one, the O, F-O, the outer, what's it gonna be? Minus what?
12 square root of 42.
12 square root of 42, thank you. And then the next one.
Plus 10 square root of 30.
10 square root of 30, thank you very much. Okay, now comes the last one now. Now comes the last one, which is this one right here. Minus what?
20.
Minus
Square root
20
of 36.
square root of 36. And this is what I want to stop a minute, right? Okay. What we said last time, when we multiply two square roots that do match, what's going to happen?
It becomes the root of itself.
Yeah, it's going to be, you know, this is the square root of 36, which is just 6, right?
Yeah.
Everybody agree with that? Now, if you want to, you can go ahead and you can write the step, right? If you want to, you can go ahead and say, okay, this is square root of 36, which is 6, right? But my point is, you can skip this step. You don't have to write this step right here. You can just go from here to here, okay? If you have a square root of 11 times the square root of 11, you don't need to bother yourself by doing 11 times 11 because then you have to get the calculator out, right? If it is exactly the same square root, exactly the same stuff you see inside, you just say what? How much is that? That's 11, right? Okay? You don't have to do the step. You can do the step if you want to, but you don't have to, okay? Which means here, I can go ahead and say 5 times 4 is 20, and then I can just go ahead and write 6, 20 times 6, okay? Everybody sees that? But is it wrong to write the steps? It's not wrong to write the step. You can go ahead and actually write 20 square root of 36. But how much is 20 square root of 36? It's 20 times 6, right? Because square root of 36 happens to be exactly 6, okay? So that is what I wanted to tell you here. This example, when the two stuff match, you can go ahead and do the small shortcut, right? So now we're almost done because there's nothing to simplify here. 12 square root of 42 plus 10 root of 30, right? And then minus 120, okay? So this is how we multiply radical expressions, okay? So I'm gonna give you some of them to do, and then I'm gonna give you enough time to do them by yourself, okay? So. All right, so we're gonna insert some stuff. I let you like at least like, you know, some good 5, 6, 7 minutes, everybody. All right. So everybody can see my file here?
I can see it now. I just, at first I could only see the first one, but now I can see the other three.
It's like, I was disconnected again, I don't know what happens today at Owings Mills, it's like, okay, I'm sorry about that. So.
It's not your fault.
Yeah, I mean, I don't know what is happening today. Maybe it's not even the internet, maybe it's Teams, because what's good about Zoom is usually you don't get those problems with Zoom. All right. So, and in the last one here, the last one is just 7 minus root 3, parentheses 7 minus root 3. Okay, so I'm gonna give you some good time. Try to do them, please. All right, so 1 more minute. So we can try to go over these. All right. So when you come back, if you come back, so right here, the first one, what's going to be the who's going to tell me the steps? The first one, please.
I believe, can I take a crack at it?
Yeah, go ahead, please.
I believe first you're going to distribute 10 to both radicals. So you're going to end up with root 50 and root 20.
Thank you. That's absolutely correct, right? And then, do you stop right here? Are you done, or can you do something with
I
this?
believe you can simplify them further.
Uh-huh.
Normally you'd do a GCF, but I don't think that would work in this situation. Hold on, let me grab my calculator.
Yeah, so you know, you have just to see if each number can be broke down into a perfect square with another number. So here, you know, the GCF is a little bit, you know, it's simpler than that. 50, for instance, we can break it down into what number? What couple? Good couple?
5 and 10.
5 and 10 is, you know, we can have better than that, because 5 and 10, neither of them is a perfect square, right?
Oh, 2 and 25.
2 and 25, thank you. And then the 25 gets out, it becomes what number?
5, so that would leave us with 10 root 2.
Yes, and it's going to be 5 root 2, right? And then this one, the 20 can be broke down into 4 and
5.
5. And the 4 gets out to become a 2, it's going to be 2 root 5, right? And that's going to be our final answer. Okay. So again, we are learning here 2 things. The first thing is how to distribute. That's the first thing we're trying to learn here. And the second thing is how to simplify after we distribute, right? Okay, and that we started like last week. Okay, so that is the final answer. And then the next example right here, the one in underneath is this one right here. What you gonna do? Who tells me how much is this? Somebody.
I can do it.
Yeah, go ahead, please.
It would be, the first one would be multiplying -5 with the square root of 15 by 3 with the square root of 3, which would be -15 and the square root of 45. Thank you. The next one would be -5 with the square root of 15 times 2, which would be -10 with the square root of 15.
Thank you. Can you simplify something, or are you done?
No, you can simplify. The 45 will simplify to 9 and 5.
Yep.
So multiply -15 by 3, which is -45 with a square root of 5. And then the other one, it's simplified. So it's -10 with a square root of 15.
Thank you. That's exactly very good, right? Thank you very much. Okay, so now the one on the right side, the first one right here, this one. Okay, so when you multiply these two, what's going to happen? It's going to be 4. Can somebody tell me?
Well, don't the positive and negative square root of 5 cancel out?
You mean after? After, or you mean from the beginning?
I guess after. That's my
Yeah, so tell me what are the steps? Okay, we're going to do the step together. Okay, you see the first arrow here, the first one. You're going to multiply the 2 root 3 by 2 root 3, right? 2 squares of 3.
4 square root of 9.
Exactly, 4 squares of 9. You can write it down.
Sorry. You
all.
said when you have 2 of the same square roots, you don't have to go through that process. You just pull it out.
Yes, so that might 4 times what then?
3.
4 times 3. That is like a cool shortcut, right? But you know, you can write 4 squares of 9 and then wait for the next step to write 3, right? Okay, but that's just a shortcut. Okay, but if I don't like shortcuts, I write 4 squares of 9. Okay, so because sometimes we don't like shortcuts. So right here, what is the next one?
-2 to the square root of 15.
Thank you very much. And then the next one right here is going to be what?
+2 square root of 15. So they cancel out.
That is absolutely correct because they are opposite. They cancel out. And what is the last number?
Well, we don't even have to do it. We know the 5 comes out, but it'll be negative.
Yes, thank you. -5. It's, again, to use a shortcut, right, is -5. It's going to be 12 minus 5, which is 7. Okay, so that is the last answer is 7. Okay, so look. So this one we just did. Does it resemble a formula? Do you recall, does it look like some formula we have seen before? I mean, one side of the formula?
It looks like
Uh-huh.
root of A times square root of A equals A.
Yeah, I mean, yes, we use that, right? We use that stuff. We use roots of A times roots of A is equal to A. But in general here, I was thinking about A plus B times A minus B, right? Look at the two parentheses. The two parentheses don't they look alike? What is the only difference between them?
One has a leading coefficient of 2 and the other has a leading coefficient of 3.
No, they're exactly the same right here. You see, I mean, I'm not saying about the next one, the one we just did. The one we just did, the two parentheses are exactly the same except for the signs, right? This is a plus, this is a minus, right? Okay.
Actually, it looks like the end result of a difference of 2 squares to me.
Exactly. Thank you very much. So what I was talking about, A plus B times A minus B. And this is A squared minus B squared. Just to say, if one of you has noticed that, you even can go faster than what we did. You can say, okay, this is A squared minus B squared, right? But you know, you don't have to notice that. Okay, the last one here looks confusing, but it's not. We're gonna practice exactly what we did. Look, when we multiply these two together, we're gonna multiply the numbers together, which is 6. And look, the radicals, don't they look alike? Aren't they the same radical? They are exactly the same radical, right?
Yeah.
Since they are exactly the same radical, what I write then?
You put 6 times 2 times, it'll be 6 times 2p.
Exactly. Everybody agrees with that? Squares of 2p times squares of 2p is exactly 2p. I even don't waste my time writing the middle step. I don't waste my time writing the middle step. This is exactly 2 times p, right? Okay, so the next one right here, the next term, this times this. The 2 is multiplied by nobody except 1 is plus 2. And we just group everybody under the same radical. You see 2p times q, 2p times q. That's it. We don't overdo it, you see? We don't need to overdo this. And then the next one here is going to be 3. And 3 is multiplied by 1 here, the one in front. And then square root of 2p times q again, right? And the last one, who tells me what's the last one going to be?
It's going to be q.
It's going to be q. Everybody agree with that? Because they exactly match, so it's going to be q. So it's going to be 6p, right, plus 5 square root of 2pq plus q, right? Again, why they give you this example? Even if the example is full of variables, just to tell you, actually this is the same thing, right? We apply the same stuff we applied. That is the reason they gave you this example. On my test, I even don't need to put variables. I just give you the regular numbers, okay? All right, the last one right here, of course, it's going to be 7 times 7 is 49, right?
What is
Minus what? 7 square root of 3. Minus what? Another 7 square root of 3. Now tell me the last number. What's the last number is going to be? Plus what?
3.
Plus 3, thank you. Again, we don't need to write the shortcut, which is plus square root of 9, which is actually 3, right? It's going to be 52 minus 14 square root of 3, right? So this is how we multiply radical expressions, okay? So, and for the division of radical expressions, we're gonna, it's the same formula actually. When you have a nth root of d divided by c nth root of d, we can go ahead and divide the numbers together. It's going to be a over c, and then you can group these two under the same root, d over d, right? Exactly the same thing with the multiplication. It just tells you, you have right to group, radicals when it is a division. You have right to do that. You can do that, okay? So for instance, if I have this example right here, and on the test, we're going to do rather the, we're going to do rather the, the division. I mean, the multiplication rather on the test. I like it better. So for instance, we say 24 square root of 5 divided by 4 square root of 80 or 45, right? See that? This type of division, what's the formula tells me I can do? I can go ahead and divide the numbers together, right? I can go ahead and say 24 divided by 4 is how much? See, I can say 24 divided by 4 is 6, right? And then these two, if I want, I can group them under the same radical, hoping that it's going to help me out, okay? Hoping that this will help me out. If it doesn't help me, I still can do it. I'm allowed to do it, okay? Was that helpful? The fact to group 5 and 45 under the same radical, is that helpful? We're going to see. We don't know yet, right? Can we simplify the fraction anyhow?
We could divide both by 5
by
and give
5,
you 1
right?
and 9, I believe.
Thank you very much. It's going to be 6 square root of 1 over 9. And is that a perfect square? Of course it is. 1 is a perfect square, 9 is a perfect square. So what is the squares of 1 over 9? Can you tell me what fraction is going to be?
1/3.
1/3, thank you. It's going to be 6 times 1/3, which is 2, right? You see, we are allowed to do that. So if I give you this one right here, go ahead. Can you simplify this fraction right here? Of course, for teams, of course, we don't need I don't need for you to type your name. Teams has a very good feature, and I can go ahead and just download the attendance, All right, and it tells me, you know, who's been here, who's left, etc., etc. Right. So that's a good feature. Okay.
We can't hear you.
You cannot hear me?
Oh, now I can.
Yeah, I was letting you a couple of, you know, seconds to finish this.
Oh.
Okay, so did you finish it? Have you finished it? Tell me what you got, Natalie?
35 divided by 7 is 5.
Uh-huh.
And then you would do square root of 80 over 5.
Okay.
And you could simplify that to, what's 80 divided by 5?
You see, I'm not good at mental math.
16.
It's 16, right? It's 5 squares of 16, and then square
And
root
that's
of
4.
16 is how much? It's 4, right? And 5 times what is?
20.
20. All right.
I had to do that on the fly.
Yeah. So you see, okay, so that is what you got, you know, for addition 3.4, right? And multiplication 3.4. Of course, you know, in OAD3 for each topic, we don't do like the depth of the topic. We don't do that, right? We don't do the depth of the topic. So and that's okay. This is math, you know. We usually deal with the foundation, the basics, right? So you have to know the basics, you know, how to deal with radicals. Of course, in math, if you keep doing math, you know, you will see we have a lot more to to say about radicals, stuff like that. Okay, but here in OAD3, we just want to know how to do the basic addition, basic multiplication, basic division, right? And this is what you're going to see on the quiz. By the way, the quiz will be available right after class 12:30. And if I'm not mistaken, I have set it up until Thursday. I mean, today is, yeah, Thursday's noon. Submission time, right? So if I go to Simon right here, I mean, if I go to Brightspace, hopefully I have, so let me first remove my stop sharing. Okay. So if I go to Brightspace, you will see quiz number 2. So let me share my screen. Okay, so that is Brightspace right here. So when you go to Brightspace, can you see my screen?
Yes.
Yes, that is, you go to your class right here. Quiz number 2, do you see it? Available 12:35 until October 21st at 2 o'clock, submission time, right? Okay, so you click on this to see the quiz, just like quiz number 1. You click on this quiz to see it. Now, you have to always keep in mind, you have 35 minutes to do it, and then about 10 minutes to upload it, right? Okay, it's like, you know, the quiz has how many questions? Maximum 5 questions, okay? So 35 minutes is way more than enough, right? So, and then if you open the quiz at 12 o'clock, you have until 12:35 to work on the quiz. Now the 10 more minutes is to submit your quiz. Where you submit it, not in the quiz stuff. No, because unfortunately there is no option to upload your work here. I created, you go to assignment, right? And then submit your quiz to here. You see that assignment right here? Submit your quiz to here, okay? This is where you're gonna submit your quiz. All right, everybody? And you have until Thursday noon. If I don't see your submission here, in this case here, if I don't see it Thursday noon, or if you get confused about submission thing, you get confused about it, and you don't send me your quiz before that time, you will have 0. I think 24 hours and a half is more than enough, right? This is more than enough to do like 5 questions, okay?
So in order to access it, do you hit update? That's how you see it?
No, you know, over the access is right here. You go to quiz right here.
Yeah.
Are you going to see quiz number 2?
Yes.
You just click on it.
Oh, I think I know what the problem is. It's the quiz. It doesn't open until 5 minutes after class, and then
Yeah,
you'll be
like
able to
right here,
access
it's
it.
12:35. Okay, you guys trying to open it? No, not now.
I just wanted to see, so I know.
Yeah, now it's gonna open 12:35, and then don't open it until you are ready to do it, because as soon as you open, it's timed. Okay. Don't open the quiz until you are ready. You have 35 minutes for yourself. Don't open the quiz until you have 35 minutes for yourself that you know you can do the quiz and finish it, okay? Because as soon as you open it, the quiz is timed and the time will be running. And it's very easy for me to go to everybody and see when they started the quiz. If I see you started, you open the quiz at 12 o'clock, and then you send me your submission at 1 o'clock or 1:50, I don't accept it, okay? When you open it, you have 45 minutes before I see your submission, okay? Which is more than enough. It's only 5 questions, okay? You take a free paper, you write your answers on the free paper, you take a picture just like in the test, and you submit it. When you submit the teacher, you go here to upload your practice, to upload your pictures or your PDF file, you go here. Submit your quiz to here, right? You click on there, and then you upload your file, okay? All right, everybody. Good luck to everybody. That is, you know, it counts for 5%. Okay, and of course, you know, it is a take-home quiz, so obviously we cannot prevent you to use your notes. But what is not acceptable is 2 people to do the quiz together. That is not acceptable. The work has to be personal. Okay. Thank you, everybody.
Thank you.
Please don't miss the quiz, please. Okay.
Thank you. See
Thanks.
you Thursday.
See you Thursday. Thank you.
Rest of the day.